Okay, so we're going to look at how fluorescent tubes work. Firstly, inside the tube we've got argon gas, okay, and that's within the argon gas we've got some mercury vapor inside it, and then we've got these filaments. And if you apply a large enough potential difference across those filaments and the current flows and it heats up, it will start to emit electrons. This process is called thermionic emission. And between this filament here and the one on the other end over here, there's going to be a large enough potential difference that these electrons get accelerated. So they move towards the left in this case. And when they do that, they're going to collide with the mercury atoms. Okay, so these free electrons are going to collide with the mercury atom like this. Okay, and they're going to cause it to excite to a higher energy level, and then it's going to de-excite back down. Okay, when it de-excites back down, it's going to emit some UV photons, okay, because that energy gap is large, so it emits a high energy photon, a UV photon. And this UV photon is going to get absorbed by the phosphor atoms in the coating of the fluorescent tubes. Okay, so if you look at the phosphor atom, it's going to absorb this UV photon and it's going to move to a high energy level, and then it's going to move back down. But when it moves back down, it's going to move through intermediate energy levels. So these energy gaps are smaller. So that means that the photons emitted will have small energy and they will correspond to photons in the visible spectrum. So we will be able to see this light that's emitted. Okay, to summarize, we've got current flowing through the filament, and this is going to cause it to heat up and emit electrons. This is called thermionic emission. Okay, then these electrons are going to get accelerated by the potential difference, which creates an electric field, and they get accelerated to the other end, and they're going to collide with the mercury atoms. These mercury atoms, electrons inside the mercury atoms, get excited to a higher energy level. So the free electrons are causing the atomic electrons in mercury atoms to move to a higher energy level through that collision and by transferring the kinetic energy. These atomic electrons in the mercury atom will de-excite back down to a lower energy level. That's basically de-excitation. And when they do that, they will emit photons with energy corresponding to the difference in the energy between those two energy levels. Okay, and this is a UV photon, which we won't be able to see. However, the phosphor coating, that phosphor atoms in the coating of the tube will absorb these UV photons. Okay, so the electrons in them will absorb it, and these electrons get excited to a higher energy level, and they'll de-excite back down. But when they de-excite back down, they don't go straight back down to the original one, because if they did, then they'll just emit a UV photon, which you won't be able to see. But they de-excite through an intermediate energy levels. Okay, so the energy gaps are smaller. Okay, so that means the photons emitted will have smaller, less energy, so they'll have a longer wavelength, and we will see this light.